Awesome. Yes, so excited to speak to you about like kind of like what we're building with Prime Intellect and kind of like the direction to really build for kind of like a pretty radically different world of like AI progress. Yeah, so for context, let's see where I need to point this. Like what we're building is basically like a peer-to-peer compute and intelligence protocol, really with the goal to make compute and as a proxy of it, intelligence kind of like this widely accessible commodity, which kind of like powers like all the things like we talk about here, like obviously from agents to like all the other different use cases really that for which AI needs compute. Really like with this broader vision that like it will be the core driver of kind of like progress. And I think like one view that helps inform this a bit is this chart of let's see. Okay, it's missing from the presentation. But basically, it's really this view that I think a lot of the people like don't take almost like the exponential progress we're starting to see over the last few years serious enough that basically it's quite plausible to me that like we'll get further progress that will basically need like a radical different like infrastructure and system. And that's kind of like what we're building for. So we basically built a few different things. Like we really launched with this idea of like a compute exchange to basically onboard like all of the compute and make it like extremely accessible for like AI startups, developers, and kind of like different applications being built on top of this. And really with this idea in mind to like orchestrate that compute because it's obviously distributed across the world. So you need things like decentralized training, for example, or decentralized like inference, like to actually orchestrate kind of like this globally distributed compute. So that's like a core, almost like realization to us was like it's not enough to have like all the compute onboarded. Like you do need to really orchestrate it extremely well. And yeah, to that extent, like we're building basically this like peer-to-peer protocol to facilitate this. And I think one useful mental model is like right now, like actually it's kind of sad. It's like a lot of the compute in the world is idle. Like it could be used for something. Like it could advance science. It could whatever, like bring entertainment or like, but it's just sitting there like going to waste. And it's mainly I think like a market failure where basically we don't have the market mechanisms and the constant demand figured out yet, like globally, to drive constant demand to compute. And actually, there was a time when there was constant demand for GPU compute, which was like in the early mining days. Like a lot of the current big clouds in the AI world started actually as crypto miners. And I think we'll start to see a shift back, like to an extent, to this, almost like for the decentralized AI miners, like that basically have like really the I think one of the core values of a protocol could be constant demand basically and like facilitating like 100% utilization of those compute resources. So I'll touch quickly on our work on the protocol. So like I touched briefly on the exchange we built. That's been going on since like a year. So we onboarded like a lot of AI startups and really the core intuition is like they don't just care about like they care about multiple things on multiple dimensions, right? It's not just price, it's also like reliability, like specific properties of the compute, like how far, like how reliable is it, but also it's like how fast is the interconnect, how fast is like the internet speed, and then kind of connected. Really, we scaled like the largest decentralized train model in the world. Basically, the state of the art was like early last year, like a 300 million parameter. Then it scaled to a billion with DeepMind, and we scaled it to a 10 billion model scale. And now we're scaling it to 100 billion model scale. So it's actually like really the core intuition is like that you in normal centralized training you synchronize every training step, which could be like once a minute. And that obviously makes it impossible to do so over the internet, for example. So you need to do it co-located. You need like all the GPUs in one location. And that quickly breaks. Even the big guys like OpenAI, Google can't fit all the GPUs in one location anymore. So even they are now training decentralized. They're just doing it obviously in their own data centers with like high-speed interconnect, even across country. Like literally, like OpenAI is doing this like not like in one like little city, like across the US basically. And what we did actually is we trained over the internet, not communicating every training step, but every 100 training steps. And yeah, we basically trained this model across like Asia, Europe, and the US at like very similar efficiency to a centralized setting, by basically spending less time communicating and figuring out kind of like the algorithm to do this. And it was kind of like original work by DeepMind that we like improved and scaled upon. Actually, like also from an intuition, like chatting to them, it's like actually it becomes so relevant now to them, like that they stopped publishing their research on it. So it's actually it kind of works, and I think not enough people know about it. And I think the other interesting thing is what we did with Synthetic One is like in this kind of like new inference-time compute paradigm, like with DeepSeek, obviously very famously, and even like what O1 and the other like frontier models are doing. It actually is perfectly set up for decentralized compute because you don't need to communicate that frequently because it mainly scales through generating synthetic data, and you can distribute it extremely well, and it's not like central like synchronized pre-training. It's more like post-training where you like generate all of the synthetic data. So we basically did actually the biggest like synthetic data generation. Like we released this on the day of DeepSeek. Like we were basically like expected them to drop something, and then scaled this towards like scaling reasoning, basically for coding, for math, for those different domains. And really the intuition is that you can take something like DeepSeek and quite cheaply improve it on the dimensions you care about. Like for example, even like using crypto effectively to generate like synthetic data and basically improve the capabilities of the model. Like for way less than like in a pre-training paradigm where you need to start from scratch and you need to spend billions. Like you can literally for like hundreds of thousands or millions, like make DeepSeek kind of like much better on like use cases you care about. The other thing we did is like an extremely efficient kind of like verification scheme that enables like peer-to-peer compute. So basically a lot of the current schemes, right, it's like ZKML, OPML, like have gigantic overhead, like to the point where it can't compete with centralized compute. And we basically did a like locality sensitive like hashing scheme, which basically quite simply means that we hash the gradients and ultimately that is like much more efficient and a much cheaper overhead than, and actually like it's already integrated in PyTorch and like basically you can use it out of the box. So it's like a very low overhead. Also a lot of the AI people in the community were like pretty excited about it, which you can't really say about like OPML, ZKML. So like it works out of the box, which is quite useful. So I touched on those things. And I think like the high level is like building almost like this infrastructure that still makes sense post AGI, like for even for superintelligence. And I think it largely comes down to is like what does AI need, right? It's like it needs the cheapest compute, which at proxy is also the cheapest inference or the cheapest training or whatnot. And really that's like almost like a full stack like engineering challenge, right? It's like it's the communication protocols, it's like the different pieces of the stack. So that's kind of like what we're going for. Like we're literally like building better CUDA kernels, building better like communication libraries to train across the internet, and like looking to basically optimize each piece of the stack to ultimately drive down costs, right? Like and make it like widely accessible. And I think from a use case perspective, like obviously it's kind of like all the use cases you could imagine. And really, I think how I think about like crypto, and I think how like this will become like a gigantic market is really the crypto is extremely good at like tokenizing anything, right? And like creating markets around anything. So I think obviously we're starting to see this with agents, like with tokenized agents becoming like a new sort of like early asset class within decentralized AI. And I think we'll see this across like all the value that like AI creates can potentially be like created on chain, like tokenized on chain. So I think of like decentralized AI protocols really as kind of like fundraise mechanisms and like tokenization frameworks for AI as an asset class that really then at some point can autonomously create value and also give it back to the creators, right? It's like you could envision like a superhuman kind of like coding agent can create protocols for you, and like you get a piece of the protocols for like seeding it with compute and basically having owning a piece of that agent. So that's kind of like how we think about and I think the other thing is like I think it's quite plausible that like in a world where like intelligence is commoditized and like the ultimate value will to an extent accrue in like to compute, and like ultimately it's like a harder currency than obviously like fiat currency, probably also a harder currency than even like say Bitcoin, which like probably in a super intelligent world, like I'm not sure why you would need it. I think what you would need is like something that you can exchange for compute and intelligence, and basically that makes you almost like independent from like like shallow fiat currency. So I do think like the ultimate currency will need to be backed by compute. So that's kind of like how we build out a system. And I think another intuition is like really through this decentralized training and those mechanisms, like we really enable almost like anyone in the world to contribute compute to anything, including agents, including like models, and basically own a piece in them. So we started this with this like first decentralized trained model, but we're thinking also about model like autonomous AI researcher agent, or like an autonomous like developer that can like autonomously create value. And obviously that's still like we're early to that, but like I think that's where it gets exciting. It's like if you basically can just like make scientific progress at the only rate limiter is compute. Yeah, like you can give it 1 million of compute, you can give it 1 billion of compute. Like it will just like whatever, like at some point probably solve all the diseases or something. Like if you have enough compute, right? It's like it can just crunch through all the problems. And we're actually starting to see this, right? It's like Google released this like AI scientist, and it discovered like 3 novel solutions to diseases just on a bunch of compute. And I think like that's what I'm personally most excited for. Basically, it's like if we can like reduce almost like I think we have all these limits. It's like we have like limited amount of superhuman coders. We have a limited amount of like superhuman scientists and other things and creators. But I think won't be limited anymore in the next few like 2 or 3 years. And I think the only limiter will be to an extent capital allocation. It's like you'll like even if you have like $1 trillion worth of compute, like where do you put it, right? It's like which problems do you care about, and like also it's like what are the sustainable mechanisms by which value accrues and flows back. So that's kind of like what we are mainly thinking about. I think the video doesn't work, but like we already launched a testnet where basically on Sepolia, where anyone could run a miner, it runs a verification scheme, and contributed compute to this like synthetic data run. A lot of like awesome people already contributed to it, and this kind of is more like a technical diagram, like maybe a bit too detailed to go into in detail, but like really the core idea is that like anyone could like contribute compute to a pool of compute that then like is doing specific tasks, right? And like ultimately the main thing that happens on chain, right, is like really kind of like this verification of compute to ensure basically that like it's like honest compute contributions. So it's kind of like this hash, but then also obviously kind of like more like the peer-to-peer like rewards for facilitating the payments over the compute. And I think like of almost like what we're planning to build is like of like from 2 perspectives, right? One from the AI perspective, but then also from the crypto perspective. And I think like going through the AI perspective, like we started with this like decentralized training and synthetic data, but I think really where it gets interesting is like once you have like more like the autonomous like developer, for example, that can actually then start to improve your protocol. It's like I'm saying this jokingly like to a bunch of the biggest protocol folks. It's like, guys, like you're not like AGI built enough. Like there's no way for Ethereum to be improved by AGI. Like it's literally bottlenecked by a human process. And I think that's really what it takes to build for this world. It's like building a protocol that can like also find a different way where it's like AGI can improve it for you, like based on the requirements, but also obviously in safe ways, right? It doesn't like break it completely. So that's really like on the AI side, like how we want to almost like over time build a protocol that it builds on the EVM, like say EVM compatible, but ultimately I think long term like moving to our own L1 that actually becomes like more scalable and can ultimately also like build out a protocol and like improve it over time in a better way. And I think like some of actually like people like Ilya from Near, for example, he said the same thing to me. Was like, yeah, I hope like we can like rewrite like all of Near in like a year or 2 with like AI. And I think like that's what we're actually gonna see. It's like basically full protocols being rewritten like one shot or something. Like, and I think it's something that I think even the timelines of some of the famous protocols, I think they're not incorporating those like progress on like coding agents and general like code generation with AI. On the crypto side, like I think really touched on the end goal, but like really I think one needs to move to something that has like a lot more scale than current systems. And I think like this hyper-parallel like execution like is the only way right now, but I think they will get other models. And because I'm running out of time, I'll close with this. Like if there's any way you're interested to get involved, I would love to chat basically different ways from contributing compute to like we're obviously also hiring, but also extremely interested to collaborate with like a lot of the builders here. So yeah, would be excited to chat with you, and thanks for joining.